You put your foot down and nothing much happens. You just can't seem to accelerate and get speed up. There's certain situations where you're on the road, maybe you're on a slight incline, and gear choice is absolutely essential if you want to pick up speed quickly. So in this video, we're just going to discuss the power band. It's something we often take for granted. We think we know about and fully understand, but actually, if we can get to grips with the nuances of the power band, we can get a lot more performance from our engine and improve our 0 to 60 or our acceleration time. So in this video, we're actually going to look at a few different dyno graphs because engines are different. Different engines have different characteristics, but we're going to discuss the power band, what the power band actually is, and how you can determine your car's power band. And that little piece of knowledge, knowing where your power band is, will enable you to make better gear selections, particularly when you're looking to maximize your acceleration. So in its simplest terms, the power band is that point in the RPM range where the engine is most responsive. You get the best acceleration. There's not a precise number. You don't suddenly hit a power band in a car. You hit a graduated point at which you would regard that as the start of your power band. In some cars, it's fairly obvious. In other cars, the power builds up very, very slowly. So we're just going to discuss the differences between certain engine types. So a dyno graph is a graph of the engine's power output produced by running the car on a dyno. So if you've never had a dyno run done, it's really recommended that you do this. It can tell you a lot about your engine, particularly if you've moved away from the factory standard power output. You've done a lot of mods on your engine, or you've done some special tuning, or there's been a few choice upgrades. All these things can have a big bearing on where that power band is, and just knowing where that power band is can make a critical difference to your acceleration. So how do you spot your power band? You've got your dyno graph on you. Well, the dyno graph is made up of two graphs superimposed on each other in most cases. You've got the power, the bhp, and you've got the torque. The torque graph is relatively flat. It goes up a little bit at the start, it's relatively flat, and then it tails off. The bhp, or the power graph, tends to spike up, so you'll see it typically going up at about 45 degrees up to a peak, and then the power will tail off. So to determine your peak power band using those graphs, it would start at one point where you're producing peak power, peak horsepower, and it would end when you've produced peak torque. So those points between peak torque and peak horsepower, that really is your power band. That's where you want to keep the RPMs for the maximum acceleration. If you haven't had a dyno run done on your car, or your car is fairly standard, you can usually find some kind of dyno graph online. Just search for your specific engine and power output. Often when companies offer you tuning upgrades, they will provide a before and after power figure. So if your car is factory standard, the before power figure will typically be that baseline that you're at. So just looking at some different engines' power outputs, the different dyno plots. First of all, we take a diesel engine. Now, these have the characteristic that the power band is very, very narrow. The RPM range is somewhat limited. A lot of diesel engines will top out or redline at about 4,500, 5,000 RPM. So the power is delivered in a very narrow power band range, which really means for the maximum acceleration, you need to be changing gear quite often. Thankfully, though, on the diesel engine, the massive amount of torque is produced low down, so you don't usually have to wait very long for that power to start coming on stream. Most gasoline or petrol powered cars, if you're in the UK, experience the power up at the higher end of the RPM range. It generally starts to build up and can go right up to 7,000, 8,000, 9,000 RPMs in some cases. If you look at the high revving engines, so particularly the Wankel engine that was used in the Mazda RX models, the RX-8 is one of those standout models that has certainly garnered a lot of appreciation from fans. So the RX-8 rotary engine will have a massively high red line, but it won't produce power very low down. You really do need to get those revs up in order to get some power out of it. It's a very, very different engine, and understanding the differences of that specific engine can make a big difference to how you accelerate. And it seems to go against the grain to many drivers to hang on to those really high RPM figures. They've almost conditioned themselves to changing at 4,500, 7,000 RPM, that sort of point. Whereas in those rotary engines, you do need to thrash them up to the top end. But you look at another high revving engine, say the Honda VTEC engine, and the power comes on much sooner than it does in those rotary engines. So again, you've got a fairly wide power band to exploit. The VTEC zone is obviously that zone where the engine is producing the most power, but just looking at the dyno graph printouts of your Honda engine can help you to determine those change points or shift points that you need to be focusing on. The other type of engine we really need to discuss is turbocharged engines. So the turbo actually uses the exhaust gases to spin a turbine and compress air and pull air into the engine. So within the turbo, those blades themselves have inertia. They take a little while to spool up and they require a flow of exhaust gases. So you'll notice that the graphs for turbo engines tend to have a fairly low power band and then a sudden spike, and then they hold that power right up to the higher RPM range. So just knowing where that turbo starts to spool up really helps you to determine those shift points. So now you've identified your power band by looking at the dynos and understanding the specific nature of your engine. Where are those shift points? Why is the shift point so important? Well, you notice that when you change down a gear, the RPMs increase. When you go up a gear, the RPMs decrease. That is a factor of gearing. The engine needs to be doing a lower speed because of the adjustment you've made to the gearing within the gearbox or the transmission itself. So a couple of runs that I've just done here, we're looking at the typical day-to-day drive of going from 20 miles an hour to 50 miles an hour. And I'm going to do the first run in second gear. So it's quite sprightly. It doesn't take very long to get up to 50 miles an hour in second gear. Now, doing the same thing in third gear is interesting. My car is a turbo, so it does take a while for the turbocharger to spool up. And you can actually see a phenomenal delay as the engine starts to pick up power and eventually the turbo cuts in and then you get the power. Knowing where the car's power band is will really help you to determine those shift points. So you may want to hang on to the RPM slightly longer outside the upper end of the power band in some cases, so that when you've changed down a gear or you change up a gear, you are still in the power band. The changes you're expecting with the RPMs of the engine really still keep you within that power band. So strategically, you always want to be in that power band for the maximum or the fastest acceleration. It's probably not something you want to do for fuel economy, but you're not watching this video really if you're interested primarily in fuel economy. So it's interesting, back in the 80s when I first started driving, cars only had 4 gears. Nowadays, cars tend to have 6 gears, and we're even seeing cars with 7 gears coming out. The large heavy goods vehicles or the trucks will often come with in excess of 20 different gear ratios. So the manufacturers are really seeing the importance of allowing control as to the gearing to keep you in that power band. They've primarily done it for economy purposes, but we can certainly exploit that. If you dropped a close ratio gearbox in your car, it would typically mean that you were more in the power band in your everyday drive. It probably wouldn't be great for fuel economy, but it would help the acceleration, but you would probably lose a little bit of top end speed, but that would depend a lot on the gear selections you've made and the final drive ratio, of course. So a good driver really anticipates where the RPMs are going to be when you've changed gear. If you're coming up to an overtake maneuver, it may be prudent to drop into the higher gear slightly early, making sure that you're in the maximum part of your power band through that overtaking maneuver. Conversely, you may decide to keep a lower gear to allow you to be in that power band earlier and change gear part way through that overtaking maneuver. It depends very much on your engine and on the circumstances, the road speed and how much road you've got left, how quickly you need to do this particular maneuver and how safe it is. In wet conditions, you would probably have a different set of priorities when it comes to choosing a gear than you would when you've got maximum grip in the drive. I hope this video has just opened up the world of the power band, and rather than something we just take for granted, let's look at a dyno graph and actually work out where our car's power band is and do some of those 20 to 50 mile an hour runs and just see how quickly the car picks up and get a feel for how the car responds in those different gears under different conditions. And that will prepare us to be better drivers. We'll get better acceleration. We'll be better equipped to keep out of others' motoring lives just by overtaking or making swift progress on the carriageway without contributing to any kinds of jams or hold-ups in the traffic flow. So if you've enjoyed this video, please boot the like button because that really does help us to get out there. I've lined this video up for you, and if you haven't subscribed, please do so because we'd love you to stay tuned. Thanks for watching, and I'll see you in this next video.